In the vast silence of the universe, beyond stars and galaxies, lies a hidden order, an invisible architecture of energy and probability. Here, reality behaves like a dream, unpredictable, poetic, and utterly alien to common sense. This is the quantum world, and it's not just strange, it's terrifying. Because if the equations are right, then what we think of as reality might not be real at all. When you look around you, the chair beneath you, the air you breathe, your own hands, everything feels solid, stable, and predictable. But if you could shrink yourself smaller than atoms, you would enter a realm that laughs in the face of logic. Particles blink in and out of existence. Objects exist in multiple places at once. And observation itself, the act of looking, changes the outcome of events. This isn't science fiction, it's physics. And the deeper we look, the less sense it makes. For over a century, scientists have struggled to understand what this all means. From Niels Bohr and Albert Einstein to Richard Feynman and John Wheeler, the world's greatest minds have stared into the quantum abyss and walked away unsettled. Einstein once said, "God does not play dice with the universe, but the universe, it seems, does, and it plays with loaded dice." The early quantum pioneers were explorers of the invisible. They weren't just building theories, they were tearing apart the fabric of classical reality. They found that light wasn't just a wave, nor just a particle, it was both. And matter itself, the stuff that makes up you and me, behaved the same way. This revelation broke physics in half. Because if an electron could act like a wave, then what exactly was waving? And if reality only existed when observed, then who or what was doing the observing? One experiment would push these questions to their limits. A simple setup, a beam of light, a barrier with two openings, and a screen behind it. The double-slit experiment. It sounds innocent enough, but what it revealed changed everything. When scientists fired photons, particles of light, through the slits, they expected to see two lines appear on the screen. That's what would happen if light were just made of particles. But instead, they saw waves, ripples overlapping, interfering, as though each photon had passed through both slits simultaneously. Light was behaving like a wave. But when scientists tried to observe which slit the photon went through, everything changed. The interference pattern vanished. The photons began behaving like particles again, as if they knew they were being watched. Observation collapsed their wave-like nature into a single, measurable path. Reality, it seemed, depended on whether it was being observed. This wasn't just strange, it was existentially disturbing, because it meant that reality might not exist independently of our perception. It suggested that consciousness, or at least observation, plays a fundamental role in shaping what we call the real world. In other words, the universe might not exist until it is observed. At first, physicists tried to dismiss it as a measurement problem, a quirk of the math, or the limitations of their instruments. But as experiments became more refined, the mystery only deepened. Electrons, atoms, even entire molecules behaved the same way. Every time you looked, The rave of possibilities collapsed into a definite outcome. Every time you looked away, it returned to a shimmering sea of probabilities. And if that's true for the smallest scales, what does it mean for the cosmos at large? Are we, the observers, co-authors of the universe? Are we shaping existence itself simply by perceiving it? These aren't philosophical riddles. They are scientific questions, born from experiments that defy explanation. But what if we go one step further? What if observation isn't just influencing the present, but rewriting the past? That's the next paradox, and it's even more terrifying.
Last time, we witnessed how simply looking at the quantum world changes it, how particles seem to wait for us as if existence itself holds its breath until observed. But what if I told you the strangeness doesn't stop there? What if our act of observation doesn't just decide what happens now, but what has already happened? Scene 1. The delayed choice mystery. In the 1970s, physicist John Wheeler dared to ask a question that even Einstein might have avoided. Could the universe allow us to decide the past from the present? He proposed an experiment, a variation of the double-slit test called the delayed choice experiment. The idea was simple and horrifying. A photon travels toward two possible paths. You can choose to measure it as a wave or as a particle. But Wheeler suggested waiting, delaying that choice until after the photon has already passed the slits. And when scientists did exactly that, the photon somehow knew. Even though the decision was made after it should have been too late, the photon behaved as if it had always known how it would be observed. The experiment suggested that the future could reach back and sculpt the past. Time, that steady rever we trust so deeply, began to look more like a loop, folding in on itself. Scene 2. The retrocausal universe. If observation in the present can influence what happened before, then cause and effect, the bedrock of all human understanding, starts to crumble. Some physicists call this retrocausality. To them, every event is part of a grand network of relationships where before and after lose meaning. In this view, the universe isn't a movie reel playing frame by frame. It's more like a completed painting, every detail existing simultaneously. You and I only perceive it line by line, moment by moment, because that's how consciousness renders it. The implications are staggering. Scene 3. The quantum eraser. A later variation, the quantum eraser experiment, pushed the paradox further. In it, particles were given paths that could later be erased, removing the information of which route they took. When that path information was erased, even after the particle hit the detector, the interference pattern reappeared, as if the particle had always traveled both paths. It's as though the universe rewrote its own history to remain consistent with what we eventually knew. Reality, it seemed, doesn't commit to a story until someone reads it. Scene 4. What is time really? So what is time then? Maybe not an arrow, but a dimension woven with space. Maybe every moment, past, present, future, exists together, and consciousness merely slides through the fabric, one slice at a time. Einstein hinted at this when he said, "The distinction between past, present, and future is only a stubbornly persistent illusion." If that's true, then every second that has ever been, every heartbeat, every star's birth and death still exists, like notes resonating forever in the song of space-time. Scene 5. The human paradox. This isn't just physics, it's a mirror held up to existence. If time can bend, if reality waits for awareness to define it, then what role do we play in the universe's unfolding? Are we travelers within time, Or are we the instruments through which time becomes real? Each choice you make, each thought you have, might not just influence the future, but echo backward, reshaping the tapestry of what was. It's a thought both beautiful and terrifying. And yet, the paradox deepens. Because beneath this strange dance of cause and effect lies something even more disturbing. A reality that doesn't just depend on observation, but on entanglement. Two particles separated by light years, somehow knowing exactly what the other is doing, as if distance itself doesn't exist. Time to be continued.
In the last chapter, we witnessed how the act of observation might reach backward in time, rewriting the very story of reality. But what happens when reality itself refuses to stay separate? When two things, oceans apart, seem to move as one? Welcome to the most haunting paradox of all, quantum entanglement. Scene 1. The ghostly connection. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen published a paper that was meant to expose a flaw in quantum mechanics. They called it the EPR paradox, a thought experiment that imagined two particles born together, then sent in opposite directions across the cosmos. Quantum theory said these particles would remain entangled, meaning the instant one was measured, the other would reveal a perfectly correlated state, even light years away. To Einstein, this wasn't just absurd, it was impossible. He called it spooky action at a distance. But years later, the universe answered back, and it said, yes, the spookiness is real. Scene 2. Bell's theorem. In 1964, physicist John Bell devised a way to test this paradox. His mathematical theorem proposed an experiment that could distinguish between two worlds, one where particles carry hidden information, and reality behaves classically, local, predictable, sane, and another where there are no hidden variables, where the universe is fundamentally non-local. When scientists performed Bell's test decades later, the results were undeniable. Entangled particles behaved as if they were one system, ignoring distance, ignoring time, defying every boundary we thought space enforced. Reality, it seemed, wasn't built out of separate things, but woven together in one seamless, invisible whole. Scene 3. Quantum telepathy. We've seen entanglement proven again and again. In laboratories, photons, atoms, even entire molecules intertwine their fates with perfect precision. You can move one particle on Earth, and its partner on a satellite orbiting 1,200 kilometers above instantly knows. No signal, no transmission, no delay, only connection. It's not that one affects the other faster than light. It's that there is no other at all. They are one. Two reflections of the same deeper entity. Maybe, just maybe, the universe doesn't communicate across space. It simply is space, a living web where every thread vibrates in harmony. Scene 4. The cosmic network. Some scientists now compare this to the structure of the human brain. Galaxies and neural networks share a nearly identical mathematical pattern. Each node, a star, a neuron, connected through filaments of energy and light. Could it be that consciousness and the cosmos are built from the same design? That when we observe the universe, it's the universe observing itself, through us. If entanglement is real, then nothing is truly out there. Everything is within the same infinite field of being. You are not a speck lost in space. You are space, conscious of itself. That's the thought that keeps even the boldest physicists awake at night. But there's one more step,
one final paradox that takes us beyond science itself. A riddle so profound, some call it the edge of human understanding. It asks, if everything is connected, who or what is doing the connecting?
If everything is connected, if every atom dances in instant unison across the fabric of the cosmos, then what happens when the observer, you, enters the equation? We've seen how observation changes the past, how two particles, separated by light years, can still respond as one. But what if the same rule applies to us, to thought, to perception, to awareness itself? Scene 1. The conscious universe. Fade in. Earth from orbit. Sunlight spills across its surface like liquid fire. Physicist Max Planck, the father of quantum theory, once said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." To Planck, the mind wasn't born from the universe. The universe was born from the mind. Today, a growing number of scientists quietly wonder if he might have been right. Because at the quantum scale, there is no separation between what is measured and who measures it. Reality doesn't exist until it's observed. It waits, undefined, like an unread book, until awareness opens the page. Scene 2. The observer's paradox. Visual. A particle beam freezes mid-motion. Time slows. In the double-slit experiment, a single photon behaves like a wave when unobserved, spreading across both paths at once. But when we look, when consciousness engages, it collapses into one definite place. It's as if the universe asks, "What do you choose to see?" and then reshapes itself around that answer. Some say this means we create reality. Others, that we reveal it. But either way, the act of observation is not passive, it's participatory. You are not a spectator in the cosmic theater. You are part of the script. Scene 3. The simulation hypothesis. In the 21st century, some physicists took this further. They asked, what if reality behaves like information? Because it is information. Everything, particles, time, space itself, might be the output of a deeper computational system. This is the simulation hypothesis. The idea that the universe operates like a vast quantum computer, processing data through every atom, rendering existence only when observed. To many, it's science fiction. To others, it's terrifyingly plausible, because quantum mechanics already acts as if it's coded, bits flipping between 0 and 1, existing in superposition until measured. Maybe the measurement isn't a collapse of a wave function, but the loading of a frame. Scene 4. Consciousness as the code. If the universe is computation, then what runs the code? Could consciousness, the silent witness behind your eyes, be both observer and operator? Across cultures and centuries, mystics, philosophers, and physicists have arrived at the same haunting idea, that the universe is a mirror, that what we call reality is awareness experiencing itself. The quantum field doesn't live outside of you. It is you. Every thought, every act of attention ripples through the field. Small, yes, but never isolated. You've never truly been separate from the cosmos. You've only been concentrated into a form that can look back at itself and wonder. Scene 5. The fear of infinity. But that realization terrifies scientists for a reason.
Because if consciousness defines reality, then we no longer have an external, objective world. There is no safe distance from the experiment, no observer outside the box. We are inside it, participants in a story that writes itself as we read it. And that means every discovery is also a reflection. When we look for the edge of the universe, we might be staring at the boundaries of our own perception. The quantum paradox doesn't just question what is real, it questions who is real. And in that question, we glimpse something almost divine, the echo of awareness, the hum of being, the realization that perhaps the universe has always known you because you were never outside it to begin with.
In the beginning, we looked outward, searching for answers in the stars, in atoms, in equations scribbled in the quiet hours of night. We thought the universe was out there, cold, distant, a clockwork machine ticking through eternity. But the deeper we looked, the more it began to look back. Scene 1, the universe that dreams. Every discovery has brought us closer, not to the edge of space, but to the edge of our own understanding. We found that matter dissolves into energy, energy into information, and information into something we still cannot name. Perhaps, as some physicists now whisper, the universe is less a place and more a process. Not a static structure, but a living thought, unfolding itself across time. And in that process, you and I are not observers. We are participants in its dream. Scene 2, when physics meets philosophy. Science has always sought truth through measurement, but measurement itself is shaped by awareness. The moment we observe a particle, we change it. The moment we describe the universe, we alter its meaning. So what if the universe can only be understood through the consciousness that perceives it? What if physics and philosophy are not opposites, but two languages trying to describe the same eternal silence? Scene 3, the quantum mirror. Entanglement showed us connection. Superposition showed us possibility. Observation revealed choice. Each paradox pointed to one truth, that reality is relational, that everything exists because it interacts. In quantum theory, nothing stands alone. Not a particle, not a planet, not even a person. The act of existence is the act of being entangled with everything else. You are the universe observing its own reflection. Every heartbeat, every thought, every act of wonder is another equation written in the language of creation. Scene 5, the fear of meaning. For scientists, this is where all becomes fear. Because once we accept that consciousness shapes reality, we must face a deeper question. Why? Why does the universe exist in the first place? Why should it be capable of awareness at all? And if the universe is aware, if it dreams through the minds of its creatures, what is it dreaming about? The answer may be both beautiful and unsettling. Perhaps the universe isn't seeking anything at all. Perhaps it simply is. A boundless field of experience, forever becoming, forever knowing itself. Scene 6, the final realization. We stand at a strange intersection between science and spirit, between the known and the unknowable. Our telescopes pierce the void. Our equations map the invisible. Yet no instrument can measure what it feels like to be alive, to love, to wonder. And maybe that's the real paradox, that the most fundamental element of reality is not matter, not energy, but awareness itself. The cosmos, vast and ancient, has found a way to look at itself through your eyes. Scene 6, the final realization. Maybe the universe isn't a place we live in. Maybe it's a question we're helping it answer. Every discovery, every act of curiosity, every whisper of awe is the cosmos remembering itself, one thought at a time. And so, in the end, the terrifying truth of quantum reality is not that the universe is strange, but that it's intimate. We are not apart from it. We are it, briefly conscious, briefly awake, swimming in the infinite sea of being that has no edge and no end.